Here we have f of x is the cube root of x, and we want to identify the absolute max and the absolute min for this function. So our first step is going to be finding any critical numbers on this function. So I want to take the derivative of it. Before I do, I might need to rewrite the original. This is x to the 1 is the power when it's not written, and it's the third root, so it's going to be 1 over 3, always power over root when you rewrite. And now we can bring down that power to take the derivative. So we'll have 1/3 x to the 1/3 minus 1 is going to be negative 2/3. I'm going to set that equal to 0. And in order to solve this, I need to put negative exponents where they belong. So I have the 1/3, and I need to put x to the positive 2/3 in the bottom where that negative exponent belongs. So there's my derivative that I'm setting equal to 0. And I want to see what makes the top 0 and what makes the bottom 0. So I want to see what makes the top 0. What makes 1 equal 0? Well, nothing. 1 is always 1. So I don't get a critical number from the numerator. And then I have 3 times x to the 2/3 equals 0. So 3 times something has to equal 0. That means that something has to equal 0. This is what makes f prime undefined. So our second step is to compare end behavior to the critical numbers. We don't have any end points, so we are missing endpoints. We're not told to look from -2 to 2 or something like that. So that means we need to make ourselves a sign chart to see what the end behavior looks like. So on our sign chart, the first thing we're going to put on there is 0. That makes f prime undefined. And then we could test any number to the left. So I might test -1. I'm going to plug into the derivative. So the top of the derivative is always 1, so that's positive. The bottom I have a 3, which is positive. And then I would have -1 to the 2/3. So I just need to maybe grab my calculator and plug that in to see what -1 to the 2/3 is. And that gives you a +1. And that's because it's really -1 to the power 2. So -1 squared is going to be +1. And then you take the third root and you get a positive. So you could do it with or without a calculator. You get a positive divided by a positive, which is positive. The function starts off increasing. And then after 0, I can plug in any number. I might plug in +1. The top of the derivative is always positive. And then in the bottom, we have a +3, so that's positive. And then we have 1 to the 2/3. 1 to any power is always 1. So I get a positive there as well. So on that interval, I have a positive divided by a positive, which is also positive. So I have something that is increasing everywhere except for where the derivative is 0. So I could draw anything that's increasing, right? We could just draw a line to think about what the end behavior looks like. There's something that's always increasing, or I could try to draw this more accurately to help me. It's increasing. It has an undefined derivative, which is just kind of like a vertical line there, would be undefined, and then it's increasing again. So either way, if we think about a picture that's increasing everywhere except for where the derivative is undefined, and we want to use that to come up with the absolute max and the absolute min. Well, if we compare the critical number, which is neither a relative max nor a relative min because there's not the sign change, so we don't have a relative extrema to compare to, so we're basically looking at our endpoints. And this left endpoint is going to continue to go down. Whichever way you want to draw the graph, something that's always increasing like that. The left endpoint is going down, so there's not going to be an absolute min. It's just going to keep getting lower and lower as we look out to the left. And then the right endpoint is going up without bound. So it's just getting higher and higher. There's not a place where it's going to stop increasing on the right. So we would say there's not an absolute max. There's not a place where it stops, and that's the highest point. And then if we're looking out to the left, there's not an absolute min because it keeps going down without bound. So there is no absolute max or absolute min because it's always increasing. So it's increasing everywhere except for at x is 0, where the derivative is undefined. So really, there's no absolute extrema. There's no highest y value or lowest value y value that we're stopping at. So lots of work to figure out there isn't an absolute max point, and there is also not an absolute min point.